Hi everybody! Today we're going to do a quick video on ocean circulation and how it affects climate. This is a map showing all of the oceans across the planet, as well as a number of ridges and basins that might serve as geologic way markers for you as you're looking at this map. All the water in the oceans is connected. Water moves in the ocean based on temperature and density. This image is of something called the gyres that move water around in our oceans. These gyres move in a circular manner, and you can see that they are different based on whether or not you're in the northern or the southern hemisphere. This is due to our good friend the Coriolis effect, which occurs because of the rotation of the Earth. You can see that the gyres move clockwise in the northern hemisphere and counterclockwise in the southern hemisphere. These ocean currents that move in these gyres carry warm equatorial waters towards the poles within these ocean basins. These currents will then affect the weather on land directly adjacent to the ocean. There are two main forms of climates. There is the continental climate and a maritime climate. A continental climate is going to be a climate that occurs in the interior of a continent. This climate is much drier and is influenced by the cold and hot air that comes from other land surfaces. These climates tend to be more extreme. It's going to be hot in the summer, very hot, and it's going to be cold in the winter, very cold. A maritime climate, on the other hand, is going to be much more influenced by the ocean that it is directly adjacent to. A maritime climate is going to occur on the edges of a continent where that continental land comes up against the ocean. So you can think of Phoenix, Arizona versus Charleston, South Carolina. They're both located along a similar latitude, but Charleston has warm, moist air blowing directly next to it because of the Atlantic Ocean and the Gulf Stream. Phoenix, on the other hand, has much cooler, much drier air because it is on the interior of the continent. But why then is San Francisco so cool if it is located next to the ocean? San Francisco is famously foggy and cool even in the summertime. Circulation patterns take the warm water poleward and return cooled water towards the equator. Charleston is along the Gulf Stream, which carries warm water. You can see in this image that it is a red line. It's carrying warm water from the equator poleward in the Atlantic Ocean. San Francisco, however, is located on the west coast of America along what is known as the California Current, which you can see in this image is a blue current. This is carrying cold waters from the poles to the equator to then be warmed. So San Francisco, while it does have very humid air, which contributes to the fogginess, it is much cooler water, which gives it a much cooler climate. Additionally, the density of water changes along this path, with cold, dense, salty water sinking down towards the bottom of the ocean, while warmer, less salty water rises on top. This is all part of what's known as the thermohaline circulation system. This moves water all across our planet. You can see in this image that cool water from Antarctica travels underneath Australia and up through the Pacific Ocean, where it then warms and becomes less dense, rises to the surface, and loops around, travels over the top of Australia through Indonesia. Then it joins with warm ocean waters that have risen in the Indian Ocean. They continue underneath the Horn of Africa and up into the Atlantic Ocean, where they reach Iceland and Greenland and are cooled and therefore sink down because they are now more dense. This cool water travels past the east coast of South America and back down to Antarctica. This circulation pattern influences seasonal monsoons, seasonal droughts, and a number of other major climate-related activities. But that is a conversation for another video. If you have any questions, please let me know about this. Have a great day.